Now, this is our last one for correcting our 5-1 assignment, but it's the most popular question. That's why I'm taping it. As we're doing this, keep in mind, this is a review material. There are already 4, maybe 5 questions on the test, the final test for this semester. So that's 8 to 10% of the test is this information, okay? So now, first thing, when you're given 2 points, you're supposed to draw or write an equation of a line through, okay? You first must find slope. So finding slope. Slope is the change in y over the change in x. Excuse me, it should be y sub 1. And x sub 2 minus x sub 1. Now, the reason why these are subscripts with, there's 2 of them, you need 2 distinct points. So now I'm looking at this and I've got 2, -4, and I've got 7, -1, and I find their difference. Okay, after I find their difference here, I've got 5, and it's negative, and I've got down here, I've got -3, so I got positive 5/3 as my slope. Okay, are there any questions in determining slope? Okay, the most popular one today is when I have that y sub 2, x sub 2, people flipped out a little bit because I put the first point in the second point's position. I want to make sure you know something about this. If I had decided to do this, and some people are going, yes, that's exactly what's supposed to be, Bloom. Was there a difference in my final answer? Crazy, right? Those subscripts are there to tell you you need 2 distinct points, 2 very different points. Just make sure that you are aware that you're stacking your y's on top of the x from the same point, and you'll have the same slope all the time. But that's it with slope. The second part of this is recognizing you're going to take point slope form and knowing that point slope form has subscripts, again, for the point you're going to substitute in. And you have 2 possible choices. I'm going to just pick C. My y, my x is going to go there, my m is going to go here. This is like a Madden chalk top. It's like Monday Night Football all over again. So I've got y minus 2 equals 5/3 x plus 4. Y minus 2 equal 5/3 x plus 4. That's where we're at. That's the deal. Here's my question. Are you doing okay with it? Are there any follow-ups? Now, I expect to see the work. I'm going to let 30 be. I'm going to have you practice on one, and I'll check them. And if there's a discrepancy, we'll talk. Okay, because at this point, this is chapter 3. We're in chapter 5. We got to get to know. Be ready. Be ready to go on this. Okay. Now, with that said, a couple things I want to make sure that people are aware of. Today we're going through notes 5.2. We're looking at perpendicular bisectors. Okay, so I got a perpendicular bisector in here, and people are like, Bloom, you did this back in chapter 1. Right, everything we're doing today, we did in chapter 1. I'm just extending the ideas. We talk about equidistant, we're talking about distance from a point to a line, perpendicular bisector theorem, converse of that theorem, and we're talking about angle bisectors and the converse of the angle bisector theorem. Direction of the day. A little reminder, chapter 4 retake, Q&A is my elk time on Thursday this week. Okay, so keep that in mind. Our assignment, 5.2 worksheet, will be handed out in about 25 minutes. Okay, so you ready? We're off to the races. Maybe. Go ahead, fill that in. Look at today's objective, to use properties of perpendicular bisectors and angle bisectors. That's where we're going. Oh, by the way, that assignment we just corrected, put your name on it if you're all done, and please hand it forward. A little lightheaded, bright lights, going into the darkness. No,
Are you all right?
well, I don't know. We'll see. Are you all right? You did an assignment on time.
I do them all.
Okay, really keep in mind, part of your homework today is not just to do the assignment, but to reread your notes. Your assignment, will no lie, will take 15 minutes if you gets it. And I'm giving you that time in class to make sure you have access to me and ask questions about getting it. Okay? And as we go through today, if there are questions, ask questions about getting it, because that's the deal. That's what we're trying to get done. So we got perpendicular bisectors. Remember, a perpendicular bisector is a line segment or ray that is perpendicular to another segment, okay? Cuts that segment into two equal parts, okay? And is perpendicular to it. Perpendicular bisector. Very descriptive, but it only is helpful if you know the words, okay? And what it looks like in a picture, okay? Now, equidistant from two objects. Equidistant is just that if this is Elk River High School and this is your house, and this is a friend's house, and y'all are on different sides of town, but it's amazing, the distance into the high school is the same, equidistant. Doesn't have to be on the same line. You could have a third friend or a second friend, a third person here, the third friend, the third wheel, okay, being the same distance ideally from their house to the high school, and you are all considered equidistant to one point, okay? There's no angle value that is governing those. Now, keep that in mind as we're talking about the distance from a point to a line. If I'm talking about a distance from a point down to a line, okay, I could say, well, it's this far. Well, it's this far. But let's put it this way. If I was going to have you run from this point, touch that sidewalk, wall, street, whatever, and come back, what direction would you be actually taking? If I just told you, hey, you got to run from here to there, come back. Would you be as long as you could? Or the shortest distance between 2 points? Straight line. Still, you'd still go the shortest distance, but when you have a point and you have a segment line, or in this case a wall, it would have to be the perpendicular distance from that point to the place I want you to touch, and then return, okay? Because you're going to take the shortest because you're thinking, oh, he's going to make me do it again, you know, or whatever, but that's what we're going to be doing. If I'm looking at the distance between a point and a line, keep in mind it's the shortest perpendicular distance to that line, okay? Now, the theorem, perpendicular bisector theorem, theorem 5.2. Okay, as we're looking at this, if a point is on the perpendicular bisector of a segment, then it's equidistant from the endpoints of that segment. Okay, so what that means is I'm marking this up. Well, before I even mark it up, what type of triangle is that? The green thing? I just highlighted the stuff there. What type of triangle is green? Somebody really goes, it's the green triangle, Bloom. Okay, what type of triangle? I'm asking, is it right, obtuse? What is it? Okay, it's a cute, well, maybe. Okay, it's a cute, maybe. But what type, let's classify it by sides. Equilateral, isosceles, because we have two sides that are exactly the same. It's not the base, but it's these two puppies right here. They're telling us that this is an isosceles triangle. Remember in chapter 4, we talked about isosceles, we talked about equilateral, we talked about the perpendicular bisector of the base of an equilateral triangle is also the angle bisector of the vertex angle. Well, it still is. Except when I have a perpendicular bisector like we have here, the distance from any point along the bisector, any point, I could move P anywhere along the bisector here where I'm putting those green dots. And the distance to the endpoints of the segment that's being bisected will always be the same, okay? So if I was setting up a shuttle run, okay, with younger students, I could actually start right here at M and say, okay, you're going to run to A and run B, and then you're going to come back and see who wins. Okay, and they're all pumped up, right? And as I get older, folks, I won't make them run the same distance, because the older you are, the more distance you're capable of running. So I could actually just move along my line further out, and I could still have A and B be my places of touching and returning, and the distance covered by both participants would always be the same, okay? And that's the idea of this when we're talking about the distance to the endpoints from any point on the bisector back to A and B. As long as they start in the same spots, will always be the same. And that's why we can talk about it as kind of an isosceles triangle setup. And consequently, I can say that. Okay, and remember, when I use those letters, I can move P anywhere along that perpendicular segment or line or ray that does the bisecting of segment AB. Okay, now we're going to use this. But keep in mind, this whole time we've been doing properties. We've been learning theorems and postulates that give us property information. Okay, we know, hey, we got this perpendicular bisector thing. Here's this property. Remember converses? If you recognize the property, then you can know that it's from a perpendicular bisector. And what I'm saying that is this next slide. If a point is equidistant from the endpoints of a segment, like I have here, if a point, P, is equidistant from the endpoints A and B, equidistant from the endpoints A and B, okay, then that point P is actually on, check it out, points A and B, that point P is actually on the perpendicular bisector of segment AB, okay? So we can actually look that over, and we know that that's going to be perpendicular. That's going to be the perpendicular bisector. Those would be equal, and we'll be able to set that up. And people are like, well, why would you need that? In a question, if I look at that red triangle, they'll say, hey, what do you know about point P? And you can know, based on the diagram and the information provided, that P is actually on the perpendicular bisector without even knowing that the bisector is there, okay? So it's all about properties. It's always about that next step. And remember, perpendicular bisector we learned about in chapter 1. Angle bisector we learned about in chapter 1. It isn't about us learning about these the first time. It's about us adding to the information we know about them and how they even relate to isosceles triangles. Okay? Now, ooh, did I forget something? I did. Sorry, guys. I got carried away. I didn't say that. I apologize. Get that down. I had some people look at me, but wait, Bloom, we missed something. Remember, that works all the time. All the time it works. Now, let's slide on to that next slide. I got 2 example problems. In order to do these example problems, turn off your phone. It's your phone. Turn it off. Darn kid. It's my phone. It's right here. I got a couple of reminders coming up. That's all. Okay, you ready? So here, as we go, everybody's looking at you. Talon's phone's going off left and right. Remember, your phone just makes you stupid. That's all it does. You start worrying about it, you don't pay attention to what's going on. Studies have shown. So here we go. You ready? Yeah, because it's smarter than the person trying to pay attention to it, always. Okay, so here's the deal. Look at the diagram that what we've got. Okay, look at our diagram. I have AC, and D's the midpoint. I also have BD be perpendicular at that point. So I'm looking at BD being the actual perpendicular bisector of segment AC. Okay, so therefore I know BA and BC are congruent. Okay, Well, if they're congruent, I know that BA, BC are equal then. And therefore, by substitution, I can substitute 4x and 6x minus 10 in. And now I'm in algebra land. I've done my properties. I looked at all my markings in my figure. I surmised that that was a perpendicular bisector. The distance back to the endpoints of the segment that's bisected is always the same from a point on the perpendicular bisector. Okay, that's how I set it up. And once I do that, I just start solving for x. Now, this is so exciting when you get this going. You got negative 2x equal negative 10, x is 5. You put your little pride trophy on, you go, yeah, you do your end zone dance, and then you go on to your next problem. But we have an oopsie. We found part of the answer. If we reread the question, we'll notice that find AB was what they said. And AB mushed together like that means the distance between point A and point B, which means we need to talk about AB is 4x, and our value of x needs to be plopped in, and 4 times 5 is actually 20, because we're going to take this value of 5, pop it in, and get it done. Be careful. A lot of you are doing some great work, but we're just not finishing because not paying attention to the significant details that are going on. Okay? It's your turn. Pay attention to the markings. Pay attention to the diagram. Set up the information based on what we know, and go ahead this algebra land and get it done. It's a fantastic place. Algebra Land's awesome. It's just got some serious roller coasters. It's driving me crazy. No, my phone. Sorry. For some reason, everybody and their brother wants to get a hold of me. Okay. So here's the deal. Are you happy with the fact that looking at the diagram, PS and RS are congruent? Okay, that means S is the midpoint. And we have a perpendicular segment going from that midpoint to Q, so QS must be the perpendicular bisector. So Q is a point on the perpendicular bisector, going to R, going to P. They must be the same distance. That's how I know QP and QR are the same. And I plop those in, and I'm off to the races. Did you get N is 3? Now, keep in mind, after you answer a question, reread the question. Find QR. Well, QR is up here. That's 5n minus 7. I got to plug 3 in for n. 15 minus 7 gives me 8. Okay, so I'm happy with that. But you know something? I said that PQ or QR and QP were equal. I found QR. Well, if I put in 3 over here, 3 times 3 minus 1, that is also 8. It's a nice little check. I just checked my work. I don't need to talk to the instructor or anybody else. I know I'm right because both of them were set equal to each other, and my final answer of my variable I found allows me to find that they are actually both equal. Okay? Now it's perpendicular bisector. Let's look at angle bisector. Angle bisector theorem. If a point is on the bisector of an angle, then the point is equidistant from the sides of that angle. Remember, equidistant from the sides. A point distance from a side is a perpendicular path from that point perpendicular to that side. So when we're looking at this, if I'm talking about point S, the path that's the shortest distance from point S to the side of the angle, QP, is actually that segment, SP, that's perpendicular to the side. Okay, now that is true about this to S to R. Okay, now keep in mind, it's interesting, we just finished chapter 4 and it's all about congruent triangles. Let's look at this triangle thinking about our triangle congruence tools that we had. We have a right angles that we could totally prove are congruent because all right angles are congruent. Okay, we have an angle bisector QS, so we know PQS and RQS are congruent because of the definition of angle bisector. We further know that QS is congruent to itself because of reflexive. I have these two triangles congruent because of angle, angle, side. Okay, now people are like looking at me glazed over and say, Bloom, you said no more proofs. It's like, no, I'm just using stuff we already know about this diagram to show that although we know all this, we know those two triangles are congruent and corresponding parts of the two triangles are congruent, we now know a new property. We're talking about angle bisector. If I have an angle bisector, okay, bisected in such a way that I have a ray QS going through, if I have a point on the actual bisector of that angle, and it's got a distance perpendicular to the sides of the angle going from that point, that distance is always the same for each side. But I just talked about it through, based on the information of chapter 4, that these two triangles are congruent because of angle, angle, side, and by CP, corresponding parts are congruent, triangles are congruent. SP and SR must be congruent as well, okay? So now we are extending our knowledge beyond just the stuff we're learning today. Now, that's angle bisector theorem. Remember, we have a converse of it. Converse of angle bisector theorem. If a point in the interior of an angle is equidistant from the sides of the angle, then the point is on the angle bisector. Okay, I just do the converse of what I just did. Same idea, same stuff. So if I know that there is a point S that is equidistant from the sides of an angle and the perpendicular distance from the side of the angle, this is significant. It has to be perpendicular. If it's not perpendicular, we can't use this postulate to say that they're the same. So you got to know that they're perpendicular. Pay attention to those markings, and then you can say they're congruent. Okay? If they're congruent like that, I shouldn't say you can say they're congruent. You can say that S is on the angle bisector. So I know that S is on the angle bisector if all this stuff exists. Okay? Now, with that said, I have two problems left. Right? Let's check them out. It is your turn to kind of peruse the problems, think about the information we just looked at. LNR is congruent to QNR because this is the angle bisector. So this is an angle bisector. These are perpendicular to the ray that's doing the bisecting. R is on that ray. So 7x must be congruent to 2x plus 25, or I should say MR must be congruent to, sorry, wrong spot. RM must be equal to RP because they're congruent to each other and therefore equal by definition of congruence. So I got 7x is equal to 2x plus 25. Okay. After I set it up, I'm on my way to algebra land. Okay, it's awesome, right? Smith's excited. She's like, algebra land, yes. Okay, I'm sorry, I'm just waking Smith up. She's a little sleepy. Okay, all right. So we got 5x equals 25. X is 5. Remember, I'm right, but I'm not done. I got to go and reread and find RM. Okay, so I take that 5, pop it in there. I find out that RM, my length from R to M is 35. Now, I'm going to double check. People are like, what do you mean by double check, Bloom? I'm going to check to see if this works up here. 10 plus 25. Hey, you know something? That's 35. Totally works, totally right. Don't even have to check the key. I'm happy as all get out. I gets it. It's your turn, last one. Find FB. Now here's the deal. Every time you see a diagram, roll up your sleeves, look into it, touch it, feel it, make it yours. Okay, it's the Ross Perot of diagrams, right? Okay, he was a presidential candidate back in the way. He was an interesting fella. If you want some entertainment on some video, Google Ross Perot. Here's the deal. I've got congruent angles. I've got an angle bisector here. So CF is an angle bisector. The distance back from F to B and F to D, because these are perpendicular, must be the same. They must be by the information we know about angle bisectors, okay? Now, because of the information provided, I'm very confident to say that FB and FD are the same, and I can plug those in. And now I can solve for X, okay? I do this every time. Some people go, oh, why didn't you just set it up? Because it's one of those things, I gotta know that those things all exist, because I can change the question and go, could these be, could you find X? Can you find FB? Is there enough information provided to come to this conclusion? Okay, so make sure you're very comfortable with being able to say, no, it's not, or yes, it is. And it's all about the things I circled. It must be angle bisector. The distance from a point on the bisector back to each part of the sides must be perpendicular to those sides, okay, coming from the same point. And if that's true, I can set them equal and solve. If it's not, I cannot, okay? So after this, I'm just kind of off to the races, and I got x is 3. I plug it back in because I'm supposed to find FB, 6x plus 3, plug in 3, 21, and I'm done. You folks now have today's assignment, and you have 15 minutes, just like my previous 3 classes. Maybe 2 people all day didn't finish the assignment in class, okay? This opportunity is brought to you by the makers of Just Get It Done. Okay, have yourselves a great day. If you got questions, come on in, ask. Remember, early is better than later because of my coaching schedule, so make sure we're coming in the morning, and that is posted on the board in the classroom. Have a great day.